Hello guys, I hope I'm audible. Hello. So hit like everyone. I know many people have not joined, but we will discuss the agenda first. Till then, I'll just write some more things. So till then, you can wait so that everybody joins. So we'll cover up all these things today. Am I audible? Guys, am I audible? Okay. So everybody start writing this things. Okay, so hit like and just note down all these things that I'm actually specifying over here. Okay, so so let's consider a data set. Please write it down. This will basically be my salary, credit, and let's say this is a approval. So we are going to take this sample data set and understand how does Xgboost work. Suppose salary is less than or equal to 50 and the credit is bad. So the loan approval will be 0. That basically means he or she will not get. If it is less than or equal to 50, if the credit score is good, then probably approval will be 1. If it is less than or equal to 50, if it is good again, then it is going to get 1. If it is greater than 50 and if it is bad, then obviously approval will be 0. If it is greater than 50, if it is good, we are going to get it as 1. If it is greater than 50k and probably if it is normal, then also we are going to get it. Okay, so everybody write it down. Write it down this specific data sets. Okay, and just let me know once you are ready. So this is my data set. So how does Xgboost classifier work? Understand the full form of Xgboost is extreme gradient boosting. Okay, extreme gradient boosting. So we will basically understand about extreme gradient boosting. Because docs are not available in community session, don't worry, then I will probably upload it today after the class. Okay, now extreme gradient boosting will be actually used to solve both classification and the regression problem statement. So first of all, let's understand how it is basically Xgboost, basically how it actually, if you just talk about Xgboost, you understand that it is a boosting technique and internally it tries to use decision tree. So how does this decision tree is basically getting constructed in the case of Xgboost and how it is basically solved? We are going to discuss about it. So whenever we start Xgboost classifier, understand that first of all, we create a specific base model. Okay, suppose if I say this is my base model, and this base model will be a weak learner. Okay, and this base model will always give an output of probability of 0.5. Okay, in the case of classification problem. So suppose if I say this is probability is 0.5. Okay, then I will try to create a field over here. This field is called as residual field. Okay. So first base model, what I'm going to do, any data set that you give from here to train, it will always give you the output as 0.5. So this is just a dummy base model. Now tell me, if my probability output is 0.5, if I want to calculate the residual, that basically means I need to subtract approval minus this particular value. So what will be the value over here? 0 minus 0.5 will be minus 0.5. 1 minus 0.5 will be 0.5. 1 minus 0.5 will be 0.5. And 0 minus 0.5 will be minus 0.5. And this 1 minus 0.5 will be 0.5, and this will also be 0.5. Let's consider that I have one more record, and this specific record can be anything, because I want to keep some more records over here. So let's consider that I have one more record which is less than or equal to 50k, and if the credit score is normal, you are going to get 0. So here also, if I try to find out the residual, it will be minus 0.5. Okay. Now, the first step, I hope everybody is understood, we have to create a base model. Okay, this base model is very much important because we have to create all the decision tree in a sequential manner. So the first sequential base tree, which is again, this is also a decision tree kind of thing you can consider, but this is a base model which takes any inputs and gives by default the probability as 0.5. Okay. Now let's go ahead and understand what are the steps in constructing decision tree after creating the base model. The first step is that create a binary decision tree. So I'm going to write it down, all the steps. Please make sure that you note it down. So create a binary tree, binary decision tree using the features. Okay, using the features. Okay. Second step, we basically define, we say it as, okay, second step, what we do, we actually calculate the similarity weight. We calculate the similarity weight. I'll talk about this similarity weight, what exactly it is. If I want to use this a formula, it is summation of residual square divided by summation of probability 1 minus probability plus lambda. I'll talk about this. What is exactly lambda? It is a kind of hyperparameter again, so that it does not overfit. The third thing is that we calculate the information gain. Okay, information gain. So these are the steps we basically use in constructing or in solving, in creating an Xgboost classifier. The first step is that we create a binary decision tree using the feature. Then we go ahead with calculating the similarity weight, and finally we go ahead and calculate the information gain. So how does it go ahead? Let's understand over here and let's try to find out. Okay. So everybody write down this particular data set and just let me know whether you are ready or not. Okay. Until then, you can hit like, you can ask me any questions if there is. And mostly I did the polling. Okay. More than 50% of people wants EDA and feature engineering as our live 7 days community session. So the next live community session, I'm going to take EDA and feature engineering, which will probably start on 15th of Feb or 16th of Feb. Okay. So we will be understanding this. Okay. So the next community live session also I'm planning to announce. Okay. Okay, perfect. Now let's go ahead and let's try to construct the decision tree. As I said that let's consider that I am considering salary feature. So based on using salary feature, what I'm actually going to do, I am going to take this as my node and I'm going to split this up. And remember, whenever we are creating decision tree, in this particular case, it will be a binary decision tree. Okay, it will be a binary decision tree. So let's say that in salary, one is less than or equal to, one is greater than 50. Okay, so this two you obviously have in the case of binary. In case of credit, where there are three categories, I'll also show you how that further split will happen and how that will get converted into a binary tree. Okay, so here you have less than or equal to 50k and greater than 50k. Now let's go ahead and understand how many values are there, okay, in this salary. So if I see before the split, you can definitely see that I'm going to use this residual and probably train this entire model. Okay. Now, if I really wanted to find out the residual, initially, these are my residuals over here. So, one residual is minus 0.5. Then I have 0.5 over here. Okay. Then I have 0.5. Then again, I have minus 0.5. Then again, I have zero point 0.5. Then again, I have 0.5. And finally, I have minus 0.5. So, these are my total residuals that are there. Suppose if I make this split, okay, less than or equal to 50. First, less than or equal to 50, the residuals, what are things are there? So here I'm going to have minus 0.5, then less than or equal to 50, again I'm going to have 0.5, then again less than or equal to 50, I'm going to have 0.5, okay? And less than or equal to, again one more 0.5 is there, I'm just going to remove this, the last 0.5, which is nothing but minus 0.5. So I hope you understood this split. So half of the things came over here, the remaining half will be greater than or equal to greater than 50. So you have one value here, one value here, one value here. So it will be minus 0.5, then you have 0.5, and then finally you have 0.5. Everybody clear till here? I hope everybody is able to understand. Okay. Residuals, how do we get it, guys? See, from the base model, which is by default giving 0.5, first my data goes over here. By default probability, I'm going to get 0.5. So residual is basically calculated from this probability and approval. So this probability minus approval. Okay. So if you subtract 0 minus 0.5, sorry, I'm just going to rub this. So if you subtract 0 minus 0.5, you're going to get minus 0.5. 1 minus 0.5, you're going to get 0.5. 1 minus 0.5, you're going to get 0.5. Okay. So everybody, I hope, is very much clear with respect to this. So this is the first step. We constructed a binary tree. Now in the second step, it says calculate the similarity weight. Now how to calculate the similarity weight? Similarity weight formula is sum of residual square. Now what is residual square? Let's say that I'm going to calculate the I'm going to calculate for this, okay, similarity weight. Now in this particular case, if I go and calculate my similarity weight, it will be summation of residual square. This is my residual values. This is my residual value. So I'm going to do the summation of this square, okay, this value square. You can see over here, sum of residual square, okay. Everybody, you can see sum of residual squares. So what do you think sum of residual squares will be in this particular case? Everyone, how I have to do it? I will just take up this all values like minus 0.5 plus 0.5 plus 0.5 and minus 0.5 whole square, right? I'm just going to do the squaring of this divided by, understand what it is divided by? It is divided by probability of 1 minus probability. Now where do we get this probability value? Where do we get this probability value? We get this probability value from our base model, right? So here I'm basically going to say that we are going to do the summation of probability of 1 minus probability. 1 minus probability, that basically means for each and every point, for each and every point, what is the probability? See, probability is basically coming from the base model, right? So for each point, I'm going to compute two things. One is the probability and then 1 minus probability. And this I'm going to do the summation. Like this, I will do it 4 times. 1 minus 0.5, then 0.5 multiplied by 1 minus 0.5. And finally, you'll be able to see one more will be there, which is plus 0.5, 1 minus 0.5. Okay. So this will be your total things with respect to this. Okay. So I hope you have understood till here, where you are able to understand that what we have done. This is summation of uh, residual square, and this is the remaining probability multiplied by 1 minus probability. Now tell me, what are you able to find out from this? If you cancel this and this, this and this value is going to become 0. Okay. So this entire value is going to become 0 because 0 divided by anything is 0. Okay. So here I hope everybody has understood what is the similarity weight of this specific node. If I want to write, it is nothing but 0. Okay, of this node. Okay. So I hope everybody understood this. Now I'm going to rub this. If everybody is clear, just let me know. Okay. Let me know what it, I hope everybody has understood. So I'm just going to rub this. Okay. And probably you can actually see to it. Okay. Minus 0.5 minus 0.5 plus 0.5 plus 0.5. This is becoming 0 entirely. Okay. Parth. minus 0.5 minus 0.5. It is nothing but minus 1. Then plus 1. Okay. Now you may be considering where is lambda value. Okay. We will initially initialize lambda by 1. I'll talk about this hyperparameter. Let's consider it as 1. Okay. So here plus 1 or plus 0. Let's consider lambda value 0. Let's say for right now. Okay. I'm just going to make it lambda is equal to 0. I'm just going to talk about it because it is a kind of hyperparameter. Okay. भाई जीरो नहीं होगा ये -0.5 प्लस -0.5 प्लस 0.5 प्लस 0.5 if I do the summation. Okay, if I do the summation here you will be able to see that I'm going to get 0. Okay, so I hope everybody has got this thing and you are able to understand it. Okay, I'll talk about lambda, don't worry. Okay, so this calculation we have done and we have got the summation of weight is equal to 0. Okay, so I'm just going to rub this. And let's go ahead and calculate the summation of the weight of the next node. Okay. I am not going to explain again if you have joined late, guys. I'm extremely sorry. Okay. No, no, no. It's not first square. It is whole square. So here also if I do, so it is 0.5 plus 0.5. Now let's do it for this. If I want to find out the similarity weight, again see, I'm going to repeat it. 0.5 plus 0.5 whole square. And since there are 3 points, so I'm going to basically use probability 1 minus probability for 1 point. Okay. Then plus probability 1 minus probability second point, and then probability and 1 minus probability for the third point. Okay. And lambda is 0, so I'm not going to write anything. Okay. Now let's go and do the calculation for this node. So minus 5 minus 5 it becomes 0, then 0.5 whole square, right? So here I'm going to get 0.25. Here if you do the calculation, here you are going to get 0.75. So this value is going to be 1 by 3, and which is nothing but 0.33. So the similarity weight for this node is 0.33. Everybody clear? For this node is 0.33. Okay. I hope everybody is clear with this now. Same thing I did, right? Minus 0.5 plus 0.5 minus 0.5 whole square divided by 0.5 multiplied by 1 minus 0.5 3 times. For that many number of specific points, we'll do this and we'll calculate the similarity weight. Okay, everybody, I hope it is clear. Okay, so here you can see probability of multiplied by 1 minus probability. Okay, don't get over confused or don't see whatever I'm doing, just do that. Okay, now here I have got this, I've got the similarity weight, I've got everything. So I'm going to rub it. The reason why I'm rubbing it, because I want you to be serious. If you don't become serious, you will miss something today. I'm rubbing it so that if I give you the materials also, you should be able to later on do it. Okay, I want you to do some kind of hard work also from your side. Okay. Okay. Now the next step that we do is that calculate the information gain. Now you know how to calculate the information gain, but before that, let's do the computation for this also. For this root node also, go ahead and calculate the similarity weight of this. Okay. Debavrata, why the base model probability is 0.5? Because it is, just understand that it is a dummy model. I've just put a if condition there saying that it is going to give 0.5. Okay, just think in this. Okay, now do it for this one, guys. Root node, what it will be? See, I can calculate from here only. -1 gone. This is also gone. This is also gone. This will be 0.25 divided by something. Okay. Now tell me, guys, what should be for the root node? What is the similarity weight? What is the similarity weight for this? Do this calculation, everyone. Up one, I know it will be 0.25 divided by this will be 1.75. Are you getting this? Similarity weight. Are you getting this? Which will be nothing but 1 by 7 And if I divide 1 by 7, if I say what is 1 by 7, 1 divided by 7, it is 0.142. Okay, so it is nothing but 0.14. Yeah, so 0.14. So if I want to calculate the root node, similarity weight over here is 0.14. So I know 0.14, here 0, here 0.33. Now, see over here, we calculate the information gain. Next step. The third step, what we do is that we calculate the information gain. Now, information gain is nothing but in this particular case, the root node similarity weight we'll try to add up. So I will be getting 0.33 minus this particular top root node. Whatever split has happened, that similarity weight I'll take 0 plus 0.33 minus 0.14. Okay, so point minus 0.14. And if I do it, it is nothing but just open your calculator again, and 0.33 minus 0.14. So it is nothing but 0.19. Okay, 0.19. So here I'm getting 0.19 as my information gain. Okay, 0.125. Is my calculator wrong then? I hope everybody has got this. Okay, 0.19. So the information gain of this specific tree, I got it as 0.19. Obviously, you know how the features will get selected based on the information gain. But let's say that the highest information gain that is given by salary. Okay. Now we will go ahead and do the further split. Let's go ahead and do the further split. So I know my information gain now, it is 0.19. Okay. And information gain is basically used to select that specific node through which the split will happen. Okay, now I'll further go and do the split. Let's say that I'm going to do the further split with the next feature, that is which one? Credit. Okay, so I'm going to take credit over here. I'm going to take credit over here, and again I have to do a binary split again. But you may be considering, Krish, here are only 3 categories. How we are going to basically do this particular split, right? Because we don't know how to do split because we have 3 categories over here. So in this case, what I will do is that what we can definitely do is that in this particular case, the split that we are probably going to do is that let's consider 2 categories like green and normal on one side, and the green and normal, this is good and normal at one side, bad at one side. Okay, so here it becomes a binary split again. Now let's go ahead and let's try to see that how many data points will fall here and how many data points will fall here. So for writing down the data points, let's say if it is less than, or see, go to the path. If it is less than or equal to 50, it will go this path, and if it is B, then we are probably going to get, how much is the residual? We are going to get 1 residual over here first of all. So this is my 1 residual, that is minus 0.5. Okay, then similarly, if I see less than or equal to 50, good is there, right? Good or normal is there. So here again 0.5 will come. Here again 0.5 will come. Okay, I hope everybody is able to understand. See the second record. Less than or equal to 50, we go in this path, but it is good, we come over here. Again, less than or equal to 50, good. Again, we are going to get one more 0.5. Then go with respect to greater than or equal to 50, which is coming over here. We'll not worry about it right now. Again, less than or equal to 50, normal. Again, it is minus 0.5. Right? So this many records are definitely coming over here. Only one record is basically coming over here. Okay, then again we will start the same process. Okay, again we will start the same process. Now for the same process, what we are going to do, again try to calculate the similarity weight. Now in order to calculate the similarity weight, what I will do, I will basically say this is my similarity weight. This will become 0.25 divided by 1 minus 1.5. Sorry, 0.25. Why? Because this whole square, right? This whole square, residual square. right? Summation of residual square. But here I have only one residual, so this square it will become. And then what I'm actually going to do, I'm going to basically write 0.5 minus 1 minus 0.5. This is nothing but only for one data point. So this is nothing but 0.5 multiplied by 0.5, which is nothing but 0.25, right? Now in this particular case, I will get similarity weight as 1. Okay. I hope everybody, I'm getting it as 1. Okay. Now what about this similarity weight if you want to compute? It is again very, very simple. This and this will get cancelled. Then again it will be 0.25 divided by, if I say 1 like this, 0.25, then again it will be 0.75. I guess so. Right? Then this will also be 1 by 3, that is nothing but 0.33. So similarity weight will be 0.33. Then again I have to calculate the information gain of this node. What I will do, I will add this up. See, 1 plus 0.33, I'll add like 1 plus 0.33 minus 0. Why 0? Because the information gain, sorry, the similarity weight of this, the up one is basically 0, right? For this particular credit node, similarity weight is 0. So 1 plus 0.33 minus 0, this will be 1.33. Okay. So like this, further split will again happen over here with different node, and we will only be getting a binary split. Okay. But we will be comparing based on information gain, which one is coming good. Okay. Now let's say that I have created this path. I have designed, I have developed my entire binary decision tree, which is a specialty in Xgboost. Okay. Now what I'm going to do over here is that, see everybody, what I'm going to do, let's consider the inferencing part. Let's say this record is going to go. How we are going to calculate the output? So this first of all went to this base model. This first of all went to the base model. Okay, just write it down till then. I will take care of the things. I hope everybody is clear till here. Everybody clear? Just give me a confirmation. Can you say real world use case? भाई classification के लिए use होता है. महेश, right? Okay. Now let's go ahead and compute for this. Okay. So what I'm actually going to get over here, if I consider a new record. Write it down, everybody. I'm giving you time. I'll give you 2 minutes time. Okay. Please write it down. Okay. Just give me 2 minutes. Till then you write it down. Okay, guys. So I hope everybody has followed till here. Now let's go ahead and see how the inferencing will happen. Suppose this record is going, right? So first of all, this record will go to this base model. The base model is giving the probability as 0.5. Okay. Okay. So the first base model is basically giving zero point 0.5. Okay. Now based on this zero point 0.5, how do we calculate the real probability? Okay. How do we calculate the real probability in this? Okay. So we apply something called as logs. Okay. So we basically say log of p divided by 1 minus p. Okay. So this is the formula we basically apply in only the case of the base model. So if we try to see this, it is nothing but log of 0.5 divided by 0.5, which is nothing but 0. Okay. Log of 1 is nothing but 0. So in the first case, whenever any record goes, I will be getting the 0 value over here. Okay. 0 value over here. Then plus. Why plus I am doing? Because it will now go to the binary decision tree. Now this record will go to my binary decision tree. Whatever value I am getting from this, I am actually adding that up, and now it will go over here. Now when it goes over here, first of all, let's see which branch it is following. It is following less than or equal to 50 branch, first branch over here. Then this is bad, it will go and follow here. So here I can see that the similarity weight is 1. Okay. Now the similarity weight is basically 1 in this case. So what we do in the case of this, we pass it to a learning rate parameter. So this specifically is my learning rate. Okay. Multiplied by 1. Okay. 1 because why? Similarity weight is 1 over here. Okay. So this will basically be my first references. Okay. And alpha over here is my learning rate. It can be a very small value based on the learning parameter that we use, like how we have defined learning parameters elsewhere. Okay. On top of this, we apply an activation function which is called as sigmoid. Since this is a classification problem, we apply an activation function which is called as sigmoid, and I hope you know what is the use of sigmoid. Based on this, based on the alpha value, based on this, the output will be between 0 to 1. Okay. Now I hope you are getting it, guys. This is how the entire inferencing will probably happen. Now similarly, what I will do, I will try to construct this kind of decision tree parallelly. So we can also write our entire function will look something like this. Alpha 0 plus alpha 1, and this will be your decision tree 1 output. Okay. Then alpha 2, your decision tree output. Alpha 3, your decision tree output. Like this, alpha 4, your decision tree output. Fourth decision tree, like this, it will be alpha n, your decision tree n output. And this will be your output finally when you are trying to inference from any new record. Now the reason why we say this as boosting, because see, understand, we are going to add each and every decision tree output slowly to finally get our output. Okay. So I hope everybody is able to understand now. Yes. Now the reason why we, based on the alpha value, based on this, the output will, right, everybody clear with respect to the working of the decision tree? This is how, this is how Xgboost actually work. Okay. Don't credit further needs to be simplified? Yes. See, like this, similarly, we can split credit with the help of, like, we can make blue, green one side, normal at one side. But whichever will be giving the information gain more, that will be taken into consideration, right? Right? I hope everybody is able to understand, guys. Yes or no? And this is how your entire Xgboost classifier works. It is very, very difficult to basically calculate all those things. So that is the reason we say that Xgboost is also a black box model. A black box model. Okay. So this is basically a black box model. Is it prone to overfitting? See, at one stage, we also need to perform hyperparameter tuning. And this we specifically say pre-pruning. Okay. We tend to do pre-pruning. And since we are combining multiple decision trees, no. This decision tree is this one, this independent decision tree which I have created. Now, parallelly after this, what I'll do, I'll create one more decision tree. So it will be looking like this. See, finally how it will look. So this is my base model. Then my data, will go to this decision tree, which I have actually done as a binary split on different records. Okay. Then again, we will make another decision tree, which will again be a binary tree. Okay, the splits will look like this. Then this is my base model where I'm getting the value as 0. This will be alpha 1 multiplied by decision tree 1, which is this. Then this is alpha 2 multiplied by decision tree 2, which is this. And like this, we will keep on continuously adding more decision trees unless and until this entire thing becomes a very strong learner. Okay, so this is how we basically do the combination of all these things. Okay, so I hope everybody is able to understand about the Xgboost classifier. Everybody clear? Can I get a quick yes if it is clear? Now you may be thinking, how does regressor work? Do you want a regressor problem statement also? Right? The decision tree will get constructed based on independent features. Independent features. Okay. And again, lambda value is a hyperparameter. We basically set up lambda value with the help of cross validation. Okay. Now let's go ahead and discuss about Xgboost regressor. The second algorithm that we will probably discuss about is something called as Xgboost regressor. And how does Xgboost regressor actually work? Some fundamentalists follow in random forest. No, in random forest it is completely different. There bagging happens. Okay, bagging happens. So over here, let's go ahead with the regressor. So here I'm going to take some example. Let's say that I have this many experience, this many gap, and based on that, we need to determine the salary. My salary is my output feature. Okay. Let's say the experience is 2, 2.5, 3, 4, 4.5. Okay. Now in this gap, let's say it is yes, yes, no, no, yes. Okay. And let's say that the salary is somewhere around 40K. It is 41K, 52K, and let's see some more data set over here. 60K and 62K. Okay. Now the first step in classifier, we created a base model. Here also we'll try to create a base model first of all. This base model, what output it will give? It will give the average of all these values. What is the average of all these values? Okay, what is the average of all these value? 40, 81, 52, 60, 62. If I just do the average, it is nothing but 51K. Okay, so by default, I will create a base model which will take any input and just give the output as 51K. Okay, this is the first step. Now, based on this, I will try to calculate my residual. Now, how do I calculate my residual? I will just subtract 40 by 51K. So this will basically be minus 11K, and this will be 10K minus 10K minus 10, and this will be 1, this will be 9, and this will be 11. Okay, I hope everybody is able to get this. Oh, sorry, let's say that I make this as 42K. Okay, for just making my calculation a little bit easy. So I have 9 over here. Okay, so this is my residual. Then again, the first step is that I construct my decision tree. Now let's say that I'm going to use the experience over here. So this is my experience node, and based on this experience node, I have my features over here. So here I will take up all my residuals: minus 11, 9, 1, 9, 11. Okay, and then how do I do the split based on experience? this is a continuous feature. So I have to basically do split with respect to continuous feature, which I have already shown you in decision tree. How do we do? Okay, it has got crashed. Okay, the file has got crashed. I'll do it, wait. But the entire file got crashed. Oh, no, it did not get crashed. Amazing. Okay, fine. Some data did not get saved. It's okay. We'll do it again. So here is my residual. Here it is 40 minus this is minus 11k minus 9k. Okay. This is 1k. This is 9k and 11k. यही बोल रहे थे ना minus 9k. It's fine. So now how do I hide this? Okay. Now, so I will just take up my first node. Here I'm going to use my experience feature. I know my values, what all things are going to come. 11k in the root node, minus 9, 1, 9 and 11. Okay. Okay. I get it. So this is 42k. Okay. Now what we are going to do over here is that please hit like first of all. The first thing that we are going to do, it is the 7-day guys. Come on. Okay, hit like. You should hit like. Come on. So I'm going to do again a binary split over here. Now the binary split will happen based on the continuous feature that is experience. So two types of records I may get. One is less than or equal to 2 and one is greater than 2. Okay. Less than or equal to 2 and one is greater than 2. Now less than or equal to 2, when I do the split, let's see how many values we are getting. Less than or equal to 2, I will get only one value, that is minus 11. And here I'm actually going to get all the other values, minus 9, 1, 9, 11. Okay. Now what we are going to do after this is that calculate the similarity weight. Now here the similarity weight will little bit, the formula will change with respect to regression. So similarity weight is nothing but summation of residual squares divided by number of residuals divided by number of residuals plus lambda. Okay. Again here we are going to consider lambda as 0 because this is a hyperparameter tuning. More the value of lambda, that basically means more we are penalizing with respect to the residuals. Okay. So this will be the formula that we are going to apply. Okay. So let's see for the first number that we want to apply. So how this will get applied. Again, I'm going to write this formula here. It will be better for you. So here, let's say here similarity weight is equal to summation of residual square, and here you have number of residuals plus lambda. See, previously we were using probability and then all those things we are using. So if you want to calculate the similarity weight of this will become 121 divided by number of residual is 1 plus lambda is 0. So this is going to be 121. Okay. So here we are going to calculate the similarity weight, which is nothing but 121. Clear till here? Oh, sorry. 121. Okay. I hope it is fine. See, if we probably take alpha, let's do one thing. Okay. If we probably take if we probably take alpha is equal to 1, then what will happen? If we take alpha is equal to 1, just think over here. What may happen? We may directly penalize the similarity weight, right? We may directly penalize the similarity weight by just adding 1. Okay, so let's do that also. Suppose I say I'm going to take alpha is equal to 1. So what will happen? This will not be the formula now. Now what will become? 121 divided by number of residual is 1 plus 1. This is nothing but 65.5. So let's say that I now have 65.5 as my similarity weight. Okay. Now similarly, I will go ahead and compute the similarity weight for the next one. So here it will become minus 9 plus 9 plus 9 plus 11 whole square divided by 4 plus 1. Okay. So this and this will get subtracted. 12 square is nothing but 144. 144 divided by 5. Okay. So if I go ahead and calculate 144 divided by 5, it is nothing but 28.5. Okay. So here I get 28.5. So the similarity weight for this is 28.5. Okay. Similarly, I can go ahead and calculate the similarity weight for this, for the top one. So it will be nothing but what it will be 11 plus, sorry, minus 11 minus 11 minus 9 plus 1 plus 9 plus 11 divided by 1, 2, 3, 4, 5. 5 plus 1 is 6. So this is getting subtracted. This will be 1 by 6. Right? Oh, sorry. This will be, anyhow, this will be whole square, right? So anyhow, it will be 1 by 6 only. So 1 by 6 will be my similarity weight over here. Clear? Okay, 28.8. It's okay. Now finally, the information gain that we need to compute will be very much simple. What will be the information gain? 65.5 plus 28.8 minus what is this? Minus 1 by 6. So try to get it, whatever we are trying to get it over here. Just tell me what will be the output. Is it 98.34? So we are probably going to get 98.34. Okay. So 98.34 information gain is with respect to this record when we splitted. We'll try to compare with the split of each and every one, and whichever will be the better, we'll try to use and split it. So like this, the entire splitting will happen and sequentially the decision tree will be added. It's 60.5. Oh yeah, sorry. 60.5, 60.5 plus 28, 88. Then this will change. Just a second. 60, 88, 88, 89. 89.13. 89.13. Okay. It's okay. Understand. You don't have to worry about calculation. Automatically that things will be doing it. Okay. So you don't have to worry. Now see, we are now further the decision tree can be splitted into any number of times. Probably the next split, what we can do is that we can do next split something like this. This will be my experience. Okay. The two splits that may happen with respect to my less than or equal to 2.5, less than or equal to 2.5 or greater than 2.5. Now, if this probably gives the information gain better, then the split will happen like this. Otherwise, whichever gives the better information gain, the split will basically happen like this. Okay. I hope, like, let's say that this is the split that is required. Minus 11 is 9 is over here, and then we have 1 comma 9 comma 11. Okay, because less than or equal to 2.5, these two records will definitely go over here, and this record will definitely go over here, right? Now if I try to calculate the similarity weight for this, it will be nothing but minus 11 minus 9 minus 11 minus 9 whole square divided by 2 plus 1, right? Now in this particular case, it will be minus 20 whole square divided by 3, which is nothing but 400. To 20 into 20 is 400, which is nothing but 3. So if I go and probably use a calculator and show it to you, Um, Probably I use a calculator right now. 400 divided by 3, which is nothing but 133.33. So the similarity weight for this is 133.33. Similarly, I can go ahead and compute for this. It will be 1 plus 9 plus 11 whole square divided by 3 plus 1, right? So it will be 10 plus 11. 10 plus 11 is nothing but 21 whole square divided by 4, right? So what it is 21 whole square? If I open my calculator, 21 whole square, 21 multiplied by 21, which is nothing but 441 divided by 4 divided by 4. So this will probably 110. 110.2.25. And similarly, I can go ahead and compute for this. Okay. So if I want to compute for this, what it will be? The same thing that we have got over here, that is 1 by 6. So this will basically be 1 by 6. So finally, if I compute the information again, it will be what it will be 133.3 plus 110.25 minus 1 by 6. Obviously, this value will be greater than the previous one what we have got, that is 89.13. So definitely we are going to use this split, which is better than the previous split, right? Let's say that this split has been considered. Finally, how do we see the output? Okay. I hope everybody is able to understand, right? Let's say that this split has worked well. So I'm going to rub all these things. Okay. 110.25 is there. Now, suppose I want to do the inferencing. How the inferencing will be done? Let's say how the inferencing will be done, everyone. Quickly, how the inferencing will be done. Now, the inferencing 110.25 here, 110.25. Okay. Now, suppose any record comes from here. First of all, any record that will go, it will go to the base model. So, the base model, whenever it goes, the value is 51. Okay. 51 plus alpha 1. This is my learning rate 1. Suppose if it goes in this route, then what we have minus 11, minus 9. Okay. Whenever we go in this route, which has minus 11 and minus 9, the average of both these numbers will be considered. What is average of both these numbers? Minus 11 minus 1, 9 divided by 2. This is nothing but minus 10, right? So minus 10 will get multiplied here. Okay. Right? Suppose if it goes in this route, then here what will happen? Here will 1 plus 9 plus 11 divided by 3, average will be taken. So 21 divided by 3, 7 will be there. So this will get replaced by 7. Okay. So similarly, anything that you are doing, this is with respect to decision tree 1. Like this, we will again construct decision tree separately. And again, it will become alpha 2 by decision tree 2, alpha 3 by decision tree 3. And like this, you will be doing till alpha n decision tree n. And once you calculate this, this will be your specific output in a regression tree. Clear, everyone? So in this particular case, what will happen? You are just trying to play with parameters and you're trying to use in a different way to compute all these things. Everybody clear? Yes? I know, but again, it is a black box model. You cannot visualize all these things. So guys, just tell me, how was this experience of 7 day session on stats, 7 day session on machine learning? I think this entire year I'll be doing this 7 day session every time. Okay. Probably MySQL I will be considering in the further things. Deep learning is there. Then we'll go with Django, Flask, OpenCV, object detection, right? Decision tree I have already explained in my previous session, guys. Okay. Now let's go to the third algorithm, which is called as SVM. NLP is also there. Next is already decided by the audience, EDA and feature engineering. I've already announced it. I had given three options. Go and participate in the community post. I gave this as one option. Second option was deep learning, 7 days live session. And the third option was, what was the third option? Third option was time series. Many people opted for EDA and feature engineering. Okay. So many people, you can go and participate in the community post till 2 more days are there. Whichever I will probably be getting, I will be using that. Okay. Okay. And guys, again, it is a request for everyone. Go ahead and take up Oneneuron platform. Soon, we are going to start live classes in Oneneuron also, and it will be every day between I think 7:30, 7 o'clock to 10 o'clock. Every day classes will be there. Different classes will be there. Okay, so it will be pretty much fun. Okay, let's go with respect to SVM. Shall we go ahead with respect to SVM? And guys, if you want to support, you can do some kind of donations and all. Okay, or take up Oneneuron, try to support us as well. Okay, because again, we're trying to do the best thing for you all. Okay, so shall we start this? Yeah, shall we start this SVM? So let's go ahead and try to discuss about SVM. See, SVM is almost like decision logistic regression. Okay, so the major aim of SVM is that the major aim of SVM is that, come on, okay. Suppose if I have do data points like this, okay. We obviously use logistic regression to split this data points, right? Like this. We try to create a best fit line which looks like this, and probably based on this best fit line, we try to divide the points, okay. Now in SVM, what we do is that we not only create a best fit line, but instead we also create a point which is called as marginal planes. So like this, we create some marginal plane. So this is your hyperplane, okay, and this is your marginal plane. And whichever plane has this maximum distance will be able to divide the points more efficiently. But usually in a in a normal scenario, whenever we talk about hyperplane or whenever we talk about marginal plane, there will be a lot of overlapping of points, right? Suppose if I have some specific points, I have one point which looks like this. I may also have another points which may overlap. So it is very difficult to get an exact straight marginal planes and split the point based on this. So over here you will be able to, guys, Parth, the community poll is in my YouTube channel. Whatever videos I upload over here is for the community. I don't take any money for that. So entirely for the community. Okay. So I usually do this community sessions and last year also I do it. Every year I do it. Okay. So if you want to participate, the community post in the community section, you'll be able to see that specific thing. Okay. In Oneneuron, separately classes will also be going on. Okay. Okay. Now, this specific marginal plane should be maximum because we can create any type best fit line and probably use this marginal plane. Now, if we have this overlapping, right? If for what do we call for this kind of plane? This kind of plane is basically called as hard marginal plane. Okay. So this is basically called as hard marginal plane. Okay. And similarly, if any points are overlapping, suppose this yellow points can also get overlapped over here, and there may be some kind of errors. So for this particular case, we basically say as soft marginal plane, because here we will be able to see that errors will be there. Okay. Now in SVM, what we focus on doing is that we focus on creating this marginal plane with maximum distance. Even though there are some errors, we consider it in solving it by providing some kind of hyperparameter. Now, how do we go ahead and basically create this all marginal planes, and how do we go ahead with this? It's very much simple. Just imagine in this specific way that initially, let's consider that I have this data points. Okay. Let's say this, I have this data point. Suppose this is my best fit line. Okay. How do we give this best fit line as equation? We basically say y is equal to mx plus c, right? We basically say this equation as y is equal to mx plus c, right? No, hard marginal, it is impossible in a normal data set. Obviously, you'll not be able to get it, but definitely we go ahead with creating a soft marginal plane. Okay. Now, y is equal to mx plus c. What does this m indicate? M is nothing but slope, and c indicates nothing but intercept. Can I say that this both equations are same? Ax plus by plus c is equal to 0. Can I also say that this is the equation of a straight line? Can I say that this is also the equation of straight line? I will say that both of them are equal. Can I go ahead and say that? Can I say both of them are equal? See, if I try to prove this to you, if I take this equation and try to find out y, it will be nothing but minus c minus a, sorry, minus ax, and this will be divided by b, this will be divided by b. This will be divided by b. So here you can see that it is almost the same. In this particular case, my m value will be minus a by b. Okay. And my c will basically be minus c by b. Okay. So both the equation are almost same. Okay. So let's consider that this is my equation, and I am actually, and whenever I say y is equal to mx plus c, can I also write something like this? Y is equal to w1 x1 plus w2 x2 plus like this plus c, or plus b, same thing, no? So here also we can write y w transpose x plus b, same equation, right? We are basically using same equation. Yes, we can also write it in a different way. Okay, but at the end of the day, we are also treating something like this. Okay, I hope everybody is clear. Let's say that this slope is in this direction. If this slope is in this direction, then I can basically say this. Let's consider that the slope is minus 1. Okay, let's say that this slope is minus 1. See, it is in the negative direction. Let's say that this slope is minus 1. I'm just trying to prove that this slope is negative value. Okay, let's consider this. Okay, now suppose this is one of my point, minus 4 comma 0, and obviously this particular equation is given by, this particular line is given by this equation. Now if I really want to find out the y value, let's say that this is my x1, this is my x1, and this is my x2. Okay, let's say that I want to find out this w transpose x plus b, the y value based on this line. If I want to compute the y value based on this line, how will I compute? W transpose x basically means what? W value, what all things will be there? Okay, one value is b, right? B is intercept. Right now intercept is passing from origin. Can I say my b will be 0? Can I assume that b will be 0? Obviously, I can assume that b will be 0. Okay. Now, in this particular case, if I talk about w in this case is minus 1, which I have initialized over here. So, if I want to do this matrix multiplication, it will be w transpose can be written as like this. And this x value can be written as minus 4 comma minus 4 and 0. Minus 4 and 0. Right. So, I can basically write like this. Now, if I do this multiplication, what will my value I get? I will basically get 4, right? So, this is a positive value. This is a positive value. Now, understand, since this is a positive value, any points that are below this line, any points that I consider below this line, and if I try to calculate the y, can I say that it will always be positive? Can I say that it will always be positive? Yes or no? Similarly, if I could probably consider one points over here as 4 comma 0, 4 comma 4. Now tell me, in this 4 comma 4, if I calculate the y value, what will you get? Whether you'll get a positive value or a negative value. If I try to calculate the y value in this case, because here only positive values will be getting, right? So if I calculate the y value, will the y value be negative or positive? Just try to calculate. How do you calculate? Again, I will use y equation. This time again, my slope is -1, my intercept is 0, and here I will have 4 comma 4. Now here -4, and then this is +0. This will be -4, right? So this will be a negative value. Negative value, guys, negative. See, -4 plus 0, negative. So any points that I will probably have in top of this, any points above this plane, right? And if I try to calculate the y value, it will always be negative. So what two things you are able to get, positive and negative. So you can consider this entirely one category, this another category. At least these two things you can basically consider, right? Let me, guys, I hope everybody is able to understand this. So this will be my one category and this will be my another category, obviously. Okay. So that basically means I can definitely use a plane and split this point. Okay. I hope everybody is able to understand. Now let's go ahead and let's see how this marginal plane will get created. Okay. And what is the cost function to basically do this, or what is the cost function in making sure that the marginal plane will definitely work. Okay. Just give me a second, guys. Just give me a second. Sometime you may be thinking, no, like, Krish, how do you remember so much of maths? Right? It becomes difficult, right? So suppose let's consider an example. Let's consider an example. Suppose I say that this is my lines. Okay. Let's say I want to basically create a kind of, I have two variety of points. Okay. One is this point. Let's say I have all these points like this. Okay. And the other points I have somewhere here. Let's consider. I am just using directly good number of points so that I can split it. Okay. Because I will try to talk about it, what I'm actually trying to prove. So obviously this is my best fit line that splits. And apart from that, what I will do is that I'll also create a marginal points. So in order to create the marginal point, I may use some different color. Let's see which color. This will be my one marginal point. Remember, it will be to the nearest point over here. And basically we will construct like this. And similarly here, we will be constructing like this. I've already told you guys, this equation can be mentioned at W transpose X is equal to 0. Sorry, W transpose X plus B equal to 0. Right? I can definitely say this because AX plus BY plus C is equal to 0. So this I can also write it as W transpose X is equal to 0. Sorry, plus B equal to 0. So both are same. Okay. This I don't have to prove it. Okay. I hope everybody is clear with this. Yes. 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 Yes, I hope everybody is clear till here. Now what I'm going to do, let's represent this line also with some equation. So this line, if I want to represent, this will be W transpose X plus B. What value will come over here, positive or negative? See, from this line, anything above this plane, right? Any distance that we try to find out, it will always be negative. So let's say that I'm using it as -1 to just treat as it is a negative value. And this line that I am going to mention it, it will be W transpose X plus B is equal to +1. Okay. -1 above, +1 below. Because we have already discussed from this point, if you are trying to calculate the y value, it is always going to be plus 1. This will going to be minus 1. Here, I should definitely say this as k, okay? But I'm not mentioning k. In many articles, you'll see it as minus 1. Many research paper also, they use it as minus 1. But I would like to specify minus and plus k. But here, let's go and write minus 1 and plus 1. Okay? Now, my aim is to increase this distance. Okay, this distance. I really want to increase this distance. Now, in order to increase this, if I increase this distance, that basically means my model is performing well. So, let's say I want to find this distance first of all. So, if I write W transpose X plus B is equal to 1, and here I will write W transpose X plus B is equal to minus 1. Okay. So, what I'm going to do, I'm going to do the computation and subtract it like this. Okay. So, here obviously this will be my x1, this will be my x2. Okay. Because these are my another points, x2 and x1. Okay. So, I can write W transpose x1 minus x2. B and B will get cancelled, and here I will be writing 2, right? So, from here we can definitely write two different things. Let's see what all things we can write. So, here this is nothing but the difference between my this plane and this plane, which is given by like this. Okay. Now, always understand, whenever we consider any vectors, right? Any vectors, right? It also has something called as magnitude. So, if I want to remove this magnitude, I can divide this by W. This magnitude of W, then only my vector will remain, which is indicated like this. So, I'm going to basically divide by this particular operation. Both the side I'm dividing by this magnitude of W, and I don't care about the directions over here right now. We just care about the vectors. Now, when I write like this, okay, what is our aim? Our aim is to, can I say our aim is to, our aim is to maximize 2 by W. Can I say this, guys? Yes or no? What is our aim? Our aim is to basically maximize this, right? By updating W comma B value, I need to maximize this. Yes? Everybody is clear with this? Can I say that? Yes, I want to maximize this. Yes or no? Everybody? Yes? I want to maximize this. If I maximize this, that basically means my marginal plane will become bigger. Okay? My marginal plane will be bigger. Okay? Now, can I write along with this that such that y of I, my output, will be dependent on two different things. One is, everybody focus over here. One is that I can say that my y of I is plus 1 when W transpose X plus B is greater than or equal to 1. Okay. Everybody see in this equation what I am actually trying to specify. Such that y of I is plus 1 when W transpose X plus B is greater than 1. And when it is minus 1, that basically means W transpose of X is B is less than or equal to minus 1. Now, what does this basically mean? See, if all my values, whenever I compute W transpose X plus B is greater than or equal to 1, I'm obviously going to get this plus 1. When W transpose X plus B is less than or equal to 1, I'm always going to get the output as minus 1. I hope that is the reason why I have actually written like this. Okay. So, this too, we have already discussed why we are specifically writing. We want to increase the marginal plane, which is this. This is my marginal plane. And I'm writing one condition that my yi value will be plus 1 when W transpose X plus B is greater than or equal to 1. Otherwise, when it is less than or equal to minus 1, it is going to be minus 1. Okay. Very much clear with this transpose condition. We have already done it. Okay. Everybody clear with this? Yes. Now, on top of it, we can add one more very important point. Instead of writing such that and all, you can also say that our major aim is that if I multiply yi multiplied by W transpose X of I plus B, if I multiplied this two, this will always be able greater than or equal to 1 for correct points, right? for correct points. Because understand, if it is -1, if I'm multiplying with this and if it is a correct point, minus into minus will obviously be greater than or equal to 1 only, right? Similarly for this, it will be greater than 1. So I can also definitely say that my major aim, if I multiply y of I with this, it will be always greater than or equal to +1, which is definitely saying that it will be a positive value. Okay. So this is just a representation, guys, but understand what is the minimized cost function. This is my minimized cost function, maximized cost function. Now I'm going to again write it down. Maximize w comma b. Okay, maximize w comma b 2 by 2 by magnitude of w. I can also write something like this: minimize w comma b, and I can just inverse this, which looks like this. Are this both are same or not? Because always understand, in machine learning algorithm, why do we write minimize things? Because we are trying to minimize something. Okay, both are equivalent. This both are equivalent. And why we specifically write minimization? Because in the back propagation, when we are continuously updating the weights of w and b. Okay, so we can definitely write like this. So here my main target is to minimize this particular value by changing w and b, and I will start adding some more parameters over here. This is fine. Till here, I think everybody has got it. This is our aim and we are going to do this. Okay. But I'm going to add two more parameters in this optimizer. One is C of I and one is summation of I is equal to 1 to n. And here I will use something called as eta of I. First of all, I'll tell what is C of I. See, if I have this specific data points, okay, let's say if some of my points are over here, then is it a right prediction or wrong prediction? If some of my points are over here, is it a right prediction or wrong prediction? Is it a right prediction and wrong prediction? Tell me, guys. Is it a right prediction or wrong prediction? Is it a right prediction or wrong prediction? Obviously, it is a wrong prediction if my points are somewhere here. Yes or no, everybody? Yes or no? Just tell me. Is it a right prediction or incorrect prediction, right? So this C value basically says that how many errors we can have. How many errors we can have. If it says that fine, we can have 6 errors or 7 errors. How many errors we can have? Even though we are using the marginal plane, how many errors we can have? So here I am specifically writing how many errors we can have. This is what is specified by C of I. Okay. Eta of I basically says that what is the summation of summation. See, I'm going to write it down. Since we are doing the summation, this entire term basically mentions that summation of the distance of the values. Distance of the wrong points, wrong data points. Of the wrong data points. Okay. And how do we calculate the distance? From here to here, suppose this is a wrong point, I will try to calculate the distance from here to here. I will do the summation of this, I will do the summation of this, I will do the summation of this. Similarly, for the green point, another summation will happen from here to here, like this, here to here, and we are going to do that specific summation. So we are telling that, fine, if you are not able to fit properly, try to apply these two hyperparameters and try to make sure that this many errors are also there. It is well and good, no problem. We will go ahead with that. Try to do the summation of the data points, and based on that, try to construct the best fit line along with the marginal planes, right? Like this. Even though there are some errors over here or errors over here, we are good to go with respect to this. Okay. I hope everybody is able to understand, guys. Right? So one more thing is there, which is called as alpha SVR. SVR, only one thing is getting changed. In SVR, only this value will get changed. Okay. So I want you all to explore and just let me know. This will be one assignment for you. Only this value will be changing, remaining everything are same. Okay. Yes, Subham, right prediction to provide overfitting. Okay. So just try to, if you change this particular value, that becomes an SVR. Just try to explore and just try to find out and just try to let me know. Okay. So overall, did you like the entire session, everyone, with respect to whatever things we have discussed and all? Yes or no, guys? Overall, how was the experience? Was it good? Was it bad? Should I continue 7 days live session like this so that you will be able to learn more and more? Okay, PCA is also there, right? I'll make a separate video on PCA, guys. Please make sure that you subscribe my Hindi channel. So there also I'm uploading all the videos and making sure that I explain everything in Hindi. So please go ahead and do that. Okay, in this one more thing is there which is called as kernel matrix. Okay, SVM kernel. We say it as SVM kernel. Now in SVM kernel, what happens? Suppose if I have a specific data points which looks like this, which looks like this. So we obviously cannot use a straight line and try to divide it. So what we do, we convert this 2 dimension into 3 dimensions, and then probably we push our point like this. One point will go like this, and the white point will go down, and then we can basically use a plane to split it. So I have uploaded a video around that. Okay, and you can definitely have a look onto that, and I have also shown you practically how to do it. Okay, that is the reason I have created that specific video. Okay. Yes, so practical for all ML models. I will make sure that I'll do that again for another 7 days. But understand, explaining all the machine learning algorithms becomes a very difficult task. Okay, so great. This was it from my side. I hope you like this session. Tomorrow you are also going to get SQL projects, interview projects. I have started uploading it. You can check it in my channel. Tomorrow morning 10 o'clock it will be available to you. Okay. Okay. So thank you everyone. Have a great day. Keep on rocking, keep on learning, and never give up. Please make sure that you subscribe Krishna Hindi channel. Hit like before going. And on 16th or 15th, we will be having our next session, which is specifically on EDA and feature engineering. Thank you guys.